In this video, I'm going to go over using a couple of the modules that will make our breadboarding a little bit easier. The ones that I have shown here are the switch input, 8-input switch module, and the one on the right is an 8 LED output. And I designed these a few years ago because I started realizing that when we start getting into a lot of inputs and outputs, the circuit, our breadboard becomes really cluttered with a lot of switches and LEDs, and it's easy to make a mistake on the wiring. So I thought I'd try to kind of consolidate some of these functions into something that'll plug fairly easily into the breadboard. Just a couple of notes here. If you take a look at the bottom underneath the switch, it's labeled 0 through 7, and the outputs here are labeled 0 through 7. And the 5 volts and ground will actually plug into the supply rail, so you don't even need to hook up the power supply. The problem is that the labels on the actual dip switch itself go from 1 through 8, from left to right. So you want to ignore those. We're usually, with binary circuits, we're looking at the least significant digit, the lowest value on the right, and the most significant on the left. Also, there's a little power LED, so if that LED isn't on, you want to check and make sure that everything's plugged in correctly. The unit on the right it's actually a 10-bar LED, but we're only using 8 of the bars. In the same situation, if you take a look underneath here, we have outputs 0 through 7 shown here, and they're wired the same way, from least significant to most significant bit. One thing to be aware of, though, is that these do not have internal pull-down or pull-up resistors on the LEDs, so that if you leave them floating, they can kind of jump from state to state. So, for example, if you're only using 3 inputs and the others aren't wired to anything, you can get some kind of strange things going on. I'll show you that in a second when we plug this into the breadboard. If you take a look at the bottom of the board, you'll see that there are rows of header pins. And those are designed to line up with the 5-volt and the ground bus rails. So the way I usually do this is I align this left pin with one of the leftmost groups of 5 here. You want to make sure you're not overlapping whatever you're using to jump the wires typically. So I can plug that in, and if I turn on my power here, you'll see that it's a little hard to see, but that green light is turning on. The LED is turning on. These outputs do have a pull-down resistor network for the input board. So there's no worry there if you turn the switches on or off. They will go from a 0 volt to a 5 volt output. And all the pins connections now are connected to the bus, or not the bus rather, but each of these vertical strips is now connected to one of these pins on the switch. So that'll save a lot of wiring. The LED board, we'll plug it in next, same thing. The ground and the 5 volt pins need to line up. And if everything is good, you'll see the LED come on here. If the LED is not on, if it doesn't come on, unplug it immediately and double check your wiring. For example, if you had the 5 volts and ground switched here, that would damage the boards. So again, take a moment to measure your voltages, please, every time. I'd really like to see if we can save these boards and not have to go through repair on them. Now you'll notice, and somebody's asking about this before, why we need pull-up resistors. This chip, I put white marker on there because I wanted to make sure that I kept this unit because I had some changes on it. These inputs it's a CMOS device. We'll talk about device families probably in the next week or two. But the inputs have a very, very high impedance. The resistor network is only to limit current to the LEDs. It's not providing any pull-up function. And with these CMOS devices, the input impedance is so high that a very, very, very small amount of current can trip the input. So if I touch these pins, for example, like magic, they turn on and off. And the reason why is that I've got a small amount of current that's probably on the nanoamp range going into my finger here, through my finger. So I'm providing either a path to ground or 5 volts. And so the workaround for this is that any inputs that we're not using, we basically want to connect to ground. We could do that with a resistor, or if I just simply plug in a wire here, for example, pin 4 to ground, then if I accidentally touch it, the input's there, a little hard to see, but that input will not turn on at that point. So I'm gonna set this up now so that we have 4 switch inputs going to the inputs on the LED bar. Okay, the next step then is to wire up all of these jumper wires, and I'm jumpering 0, 1, 2, and 3 on the inputs there to inputs 0, 1, 2, and 3. Now, I have to tell you something. You have to really be careful when you're lining these up. It's very easy to be offset by 1 row if you're not looking very carefully. So take the time to double check everything. The first time I did this, everything was misaligned and I made a mistake. These were actually over 1 row here. So just double check those. So now if I turn on the switch, 1, 2, 3, and 4, those 4 lights will light up. And if I touch the input pins here, nothing changes. That's because I've got these 4 inputs here to ground, so I can't actually accidentally turn those on. And these 4 are coming from the switch, which has a pull-down resistor network. So this example, this is kind of just a test to show how this works. In reality now, we can use any of these switch inputs for inputs on our circuits. And the same thing with the LEDs. Some of the kits that you got might have been short a couple switches or a couple LEDs. Feel free to use these now. For example, for the last lab, if you're short a switch, if you've got switches and you want to wire them up, that's fine. I was actually going to show you these later on because I think it's a good exercise to learn how to wire the inputs and outputs with regular switches and LEDs. These are more for the complex circuits. But if you're short an LED or you need to get an extra input, you can use these boards for that. And we'll go over the other boards in the coming weeks when we get into the MSI subject.